This week we're going to learn about arrays. So I'm going to create a new project for lesson 7. And I'm going to create a new Python file. And we'll get rid of that, and we'll make that a little smaller. And I'm going to follow through the PowerPoint presentation for this chapter fairly closely to cover the syntax. And a lot of Python is similar to what you'll see in the pseudocode, but there are some important differences as well. So let's start at the beginning. Declaration of arrays, you might have a statement like declare string employees 50 in pseudocode. So here's the pseudocode, and the Python equivalent for that is a little odd. So it'll look something like employees equal, and then I need to create an array with 50 items in it and initialize all of them to empty string. And that's going to look like square bracket empty string for x in range 50. So this part here, it's like a loop that we saw last time. But what it's doing is basically running this piece of code 50 times, and for each of the 50 times, it's returning an empty string, and then all of that is inside of an array initializer. So square bracket creates a new array, and then this thing in here fills it with 50 empty strings. And so if I go ahead and print that, what I see when I run it is basically a list of 50 empty strings inside of an array. I can also do this with reals, like so. As sales amounts equal 0.0 for x in range 7. So now I get 7 0.0 values in an array. So when you're working with this kind of syntax, basically I treat it like boilerplate. I mean, it's just basically copy and paste. The important part is that you need the number of elements here, and you need the initial value there, and then the rest of it's pretty straightforward. So we can also declare an array with a constant size. We don't really have constants in Python, but we can do the rest of it. So, for example, that's going to be equal to size equal 5 and numbers equal 0 for x in range size. And there's 5 zeros. So to access each element, so there's the first element, and that's the last element. So since this goes 5 elements starting from 0, 0, 1, 2, 3, 4, that's 5 elements. And I can also write this as size minus 1. So this is going to be the first element is always 0, and the last element is always the size minus 1. Now another thing I can do in Python that isn't in the pseudocode is I can actually say for x in range size. So x goes 0, 1, 2, 3, 4. So this produces an array with the contents 0, 1, 2, 3, 4. So that's what it'll show here. And then the first element is going to be 0, and the last element is going to be 4. So 0, 1, 2, 3, 4, first element is 0, last element is 4. So I can store values into the array as well. So I'm going to declare the array with 5 elements, and then I'm going to set numbers, copy all of this pseudocode. So number sub 0 is 20, and we do the rest of these. And then we'll display numbers. Sort of made a mess of this. Number sub 0 is equal to 20. It looks like the book has a typo too. This double quote is backward, or the square bracket's backwards. Alright, so size is 5, numbers 0 for x in range size, and then the assignments in Python look much like the pseudocode. Number sub 0 is 20, numbers sub 1 is 30, numbers sub 2 is 40, numbers sub 3 is 50, and numbers sub 4 is 60. And then print numbers, and here we go. So 20, 30, 40, 50, 60. Let me get rid of this stuff here. So in Python, I can also write this as 10 times x plus 2. And I get the same results because x goes 0, 1, 2, 3, 4. 0 plus 2 is 2, so 20. 1 plus 2 is 3, so 30. 20, 30, 40, 50, 60. But then this is also sort of difficult to maintain, so you may prefer writing it like that. So you can also use a loop to step through the array. And I can also write it like this. And there we go. So this should produce the same results as well. And it does. So you can fetch the values the same way. We've already seen that. When you declare the array, you can also initialize the values. And in Python, we can do that in a slightly different way. So here's the pseudocode. And then the Python code, let's go ahead and display days. So the Python code is days equal and then square array, Sunday, and then I'm going to Monday, Tuesday. I would copy the string above, but these are funny quotes, not straight quotes. And if you so I want to avoid having the line be too long. Actually, I should put the comma there, break it there. So an array, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then I can also say so there's days, there's I, and here's my for loop. And then if I run it, I get the days of the week. So one thing I should point out, so the book also mentions that setting an element of an array that's past the end of the array causes an error. So for example, this days array has 7 items in it, 0, 1, 2, 3, 4, 5, 6. So when you try to set days sub 7, you get an error. And let's take a look at that in Python. So I have my days array. It has 7 items in it, numbered 0 through 6. I'm going to set days sub 7 equal to fun day, and then print, display days sub 7. And let's do this properly. So then in Python, that would look like days sub 7 is equal to fun day, and print days sub 7. And if I run it, I do get an error, list assignment index out of range, while setting days sub 7 to fun day. So there are ways to add items to arrays in Python, but just setting an element past the end doesn't work. So when an array is partially filled, you need to keep track of the top of it. So let's go ahead and implement this pseudocode. And I'm going to get rid of everything up till here. And comment that out. So let's do our declarations first. So size is 100, values is 0 for x in range size, and then count is 0, and then number is 0, and index is 0. And this should be lowercase here, so I'm going to fix that. And then for this code, so here I have an input statement. And I'll copy that. And then while number not equal minus 1 and, lowercase in Python, count is less than size, values sub count equals count plus 1, and then print, and this is another input statement, so copy that line here and change the text. It's actually the same, so we're good. So that's the while loop, and then we're going to output the results, so print like so, and then a for loop, so for index equals 0, so it's actually for index in range count, print value sub index, and that's it. So here's the whole program, and if I go ahead and run it, enter a number, so 1, 2, 3, 5, 7, 9, minus 1, minus 1. Okay, so we have a little problem. I'm going to stop this. So this number not equal minus 1 is not returning the right thing because number is a piece of text. So I need to turn this into a number, and number is defined as an integer above, so I'm going to turn it into an integer. Yep. And then I'm also going to do the same thing here. So now let's try it. And then minus 1. And then this is wrong too. This was my mistake. So I got these two lines combined. So values is equal to number and count equal count plus 1. So there we go. 1, 2, 3, 4, 5, 7, 9. And then minus 1 to quit. And then we get our numbers back. 1, 2, 3, 4, 5, 7, 9. So in Python, of course, we have a for each loop because we've been using it the whole time. We have for x in a range. You can also say for x in an array. So for example, another way to write this loop is for value in values, print value. So for example, all the numbers I enter are going to be in this values array, and then I'm going to step through each of the values one at a time and then print the value. Two, 4, 6, 8 minus 1, and then I get an array with 2, 4, 6, 8, and then I initialized it to have 100 values in it, so I get 96 other values. And then when I say for each value in values, I get 2, 4, 6, 8, and then all of those values. So usually that's not what you want, but if you want to do something like this, copy that. And then if I wanted to dump all of them, and this might not be the exact syntax the book recommends. I have to check on that. For fruit in fruits, print fruit. There. Oh, actually it does match. Good. So for each fruit in fruits, display fruit and 4. This should be numbers sub 4 according to the book. And then searching an array. Let's go ahead and grab this code. So this isn't full pseudocode. It doesn't include the declare statements, but found is false, index is 0, and then while found is false, and index less than or equal to size minus 1, if array sub index is equal to search value, then, and I need to define some of these things, then found is true. Else, index equal index plus 1, and end if and while. So I need an array So there are 5 days of the week, and I'm going to declare size equal to 5. And then we'll set search value equal to Wednesday. So what this is going to do is it's going to loop through the array until it either finds Wednesday, in which case index will be the position of where it was, or until it gets to the end of the list, in which case index will be 5. So if index is 5, that means I've run off the end of the list without finding Wednesday. But if index is 0, 1, 2, then it means I found the item. So if index less than size, print found item search value at position index. Else didn't find item search value in array. And then let's go ahead and change this. Please enter a weekday. So now we have a whole program. If I run it, if I enter a weekday, Wednesday, find item Wednesday at position 2, and then let's do Friday, position 4, but then if I look for Sunday, didn't find item Sunday in array because it only goes up to that. So now if I add Saturday and Sunday and run it, now when I, oops, I have to change size as well. So this is still not going to work. So let's change size to 7 and now run. So now it finds Sunday at position 6, but doesn't find Fun Day in the array. So you can also total and average values. This is not actual text, but so basically we have an array of values, we're looping through, calculating the total, and then displaying the average. So rather than repeating the pseudocode, let me use a slightly different version of Python. So vals is equal to an array 0, 2, 5, 6, 3, 5, 10, 1. So there's some values. And then 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 values in there. And then I need an index variable for I in range size. And then I need a total value, which is equal to 0 to start. Total equals total plus vals sub I. So now I have the total in total. And then the average is equal to the total over the size. So let's run it. And that's how you total them and then take the average. Find the highest and lowest values in the array. Basically, it's the same loop. We set the min equal to some initial value that comes from the array, so vals sub 0, and set the max equal vals sub 0. And then inside the loop, we add an if statement. So if vals sub I is greater than max, then max is equal to vals sub I. So for any value that's higher than our current max, we set the max to that value. And then we also set if vals sub I is less than min, min is vals sub I. So we're basically remembering the lowest and highest values. So total, average, min, and max. So average is still 4, the lowest value is 0, and the highest value is 10. And if we change this to 3 and run it, now it changes the average and the total. Min is now 1, and max is now 10. So you can copy arrays. Vals 2 is 0 for x in size. So now I have an array that's the same size as vals. And then vals 2 sub I is equal to vals sub I. So here's my copy of vals. Oh, I have a little problem. Oh, for x in range size. So here's my copy of vals, which is actually vals 2. And you can pass arrays as an argument. So let's call this do calculations. And it will take an array called vals. And then I'm going to tab all of this code over. And I'm going to get rid of the vals 2 stuff. And then I need my total, min, and max as local variables inside here. So those are the declares for local variables. And then I also need to know size in here. And so this is going to refer to that as a global. I'm going to call this outer vals, just so that it's completely clear that it has a different name than this. And then to run the program, I'm going to call do calcs and pass in outer vals. And if I've done everything correctly, this should work. And it does. I get the same result as before, but this time I'm passing this array here in as an argument to this module. And this module takes a parameter, which is an array, and does its business. So in the book pseudocode, you'll see the signature line here written as module do calcs, and then it takes a parameter, which is a, I'm going to assume that's a real array. So real vals sub 8, or size, or whatever. So you'll see a declaration like that in pseudocode, and that's perfectly fine. I also sometimes write them like this. Put the square bracket there. So this shows that this is an array of reals, and that's the type for vals. So you'll see this kind of declaration in C and BASIC and some other languages. But then this is considered a little more modern, and you'll see it in Java and C#. So which one you prefer may depend on which languages you work in the most. I like this because it has the type all together, but you can do it either way in your labs. So parallel arrays, basically you just have two arrays that have parallel contents. So for example, I might have an array of names. Mark, Fred, Emily, Ruth, Juan, and George. So for example, here are 1, 2, 3, 4, 5, 6 names. And then each name might have an associated grade. So 90, 80, 75, 55, 99, and 20. So these two arrays are in parallel. So this person, that's their grade, this person, that's their grade, this person, that's their grade, and so on. And since they are in parallel, I can write a loop like so for index in range size print person colon name sub index grade colon grade sub index. And then when I run this code, I get Mark grade 90, Fred grade 80, Emily grade 75, and so on. So basically it stepped through both arrays at the same time. Since the arrays are tied together, I can display them together. So that's pretty much it for this week. Two-dimensional arrays we're going to be skipping because those are considered more advanced. And same with arrays of 3 or more dimensions. So good luck on the lab, and let me know if you have any questions.